So let's work on an example together. In this example, we have the data points. We have two populations with mu1 and mu2. We are interested to find out the difference between these two populations. We know the sigma 1 is 4.1 and sigma 2 is 0.4. Mu1 minus mu2, it's like we assume that it's equal to 0. Our alpha is like that. We are working with a 95% confidence interval, so alpha is 5%. Here is the data from the samples that we get, like the sample 1 and sample 2. Sample 1, there are 18 data points from population 1, and sample 2 is the 16 data points from the second population. From the samples, the data points that we got, we find out the x bar 1 and x bar 2. So for finding out the x bar, it's going to be like sigma xi divided by n, right? So we would find out the estimate for the mu from the sample 1 and sample 2. In the question, we have been asked to find out test the hypothesis, also construct the confidence interval for it. So for this one, the first step that I want to ask you is that try to think that, first of all, which case is it? Is it case 1, 2, 3, 4? Which case is that? And then, are we working with one sample? It's obvious, right? Or two samples? You can pause the video and think about it, write down your answer, like on a piece of the paper, and then come back and listen to the rest of the question. So here we would say for the test of the hypothesis, okay, I'm going to write down here for the answer. So let's say, first of all, we said that we want to know that if it's case 1 or case 2 or case 3 or case 4. So we know we are interested, the parameter of interest is mu1 minus mu2. So it means that we have two samples and sigma 1 and sigma 2 is known. Because of that, I would write down here that we have two samples and also it's case 1. Right? Because the parameter of interest is mu and we know the variance of the population. Then for the part A, which is the test the hypothesis, what I'm going to do, I'm going to write down the 8 steps. So step number 1, so here I'm going to write down A. So step number 4, and then I'm going to write down, let's say A here, just to have more space. Okay, for test of the hypothesis. Step 1 was that find out the parameter of interest. So the parameter of interest here is mu. So we would say the difference between the mu. So parameter of interest mu1 minus mu2, right? And then step 2 would be what's your null hypothesis? So here our null hypothesis is mu1 minus mu2 is equal to 0. So delta here is equal to 0. For this one, we can also write down mu1 is equal to mu2, right? Because it's a mu1 minus mu2 is equal to 0. And then step number 3, it's out. We are going to find out the alternative hypothesis. So the alternative hypothesis, well, we can say mu1 is not equal to mu2, right? In the question, we haven't been asked, we haven't been told anything about the one-sided test. So because of that, we consider it two-sided. So step number 3, step number 4 was that write down the test statistic, right? So we want to know that what's going to be the test statistic. So here is case 1. We would write down the z observed. It's going to be x bar 1 minus x bar 2. We had minus delta, right? But the delta here is 0. Look at here. So this one here is delta observed. Because of that, this one is 0. And then divided by a square root. So we have the sigma 1 and sigma 2, right? So for the standard error, which is going to come up in the denominator, we simply write down sigma 1 power 2 divided by n1 plus sigma 2 power 2 divided by n2. So this is going to be the equation of the z observed. Step number 4, step number 5. 4 and 5 you can switch it, it doesn't matter. So it's like that. What's the level of the significance? So alpha is 5%. Okay. And then 5, 6 is that, tell me what's the rejection region. So for the rejection region, we would say that because it's, I'm going to, as a side note, I'm going to write it down here and then I'm going to erase it. So here we have the 95, so we have the z half of the alpha, because we said 95% confidence interval, so 5%, z at the 0.025 and z at the 0.025. So if we are in this area and in this area, then it's going to be, my z observed would be in this. When I say in this area, be careful. We have two methodology, we said. One is the p-value. When we are talking about the p-value, we are considering this area, comparing the area. If you are considering like the approach of just this z1, what are you going to do is that you're going to consider this length, like whatever it is. So we are talking about the length, like the length whatever we have from the point 0. So rejection region, I would say that if my z null, right, it's less than this one minus z half of the alpha, because it's the minus z half of the alpha, right? Or my z null is greater than the z half of the alpha. In that case, we would say that we are in the rejection region. Okay, so here is step number 5, 6. So number 7 is like the computation or calculation. So when we say computation, what does it mean? It means that find out z null, z observed, and also the alpha, what's going to be the related z value for alpha. So what I'm going to do here is that I will write down for the z null or z observed is going to be equal to the x bar 1, 34.33 minus this one, 31 point, like x bar 2, 31.87 divided, and then here I have the square root of the sigma 1, where is it? 4.1. So 4.1 power 2 divided by n1, 18, and then plus 0.4 power 2 divided by the 16, right? And here we can find out the z null. So from here, when we do the, where's my calculator? So when we put it in the equation, so it's gonna be, I'm just gonna put it here. So it's gonna be 2.46 divided by 4.5 plus, okay, so it's 2.5320. So let's say 2.53. So this one is going to be equal to the 2.53. And also we know that alpha is equal to the 0.05. I'm going to just write down here because I want to make the conclusion, write down the conclusion over there. So for the z at the half of the alpha, so we are looking for the z at 0.025. So I'm going to write down here z at the 0.025. Then we go to the z table. Let me just see z table. Maybe at the back of the most of the stats book, but we have it on, like, it's, I posted on our course website as well. So let's say for z, we are looking for the z at the 0.025. 0.025, 25, so it's going to be 1 point. So the way that you would read it, it's going to be, so here we have the -1 and we have the +1. So what I'm going to do is like that, you're going to look at the body of your table for z. So when it's like 0.025, I will look at it and try to find out where is the 0.025. Like here I have the 0.0255, 0.0249. So it's going to be between this and this. I'm going to get the 1.9495. So I will read the, you can get do the interpolation as well, but it doesn't matter because most of the time the difference is a lot. So I'm going to consider 1.95 for this one. I would assume that is 1.95. You can write down even 1.96 as well. So let's say 1.96. Make it bigger. We get the bigger number. So 1.96. So that's so we did the computation part. Now we need to go to the conclusion part. So for the conclusion, like step number 8. So here, let me just put a line like this. So step number 8, you can write down 8 as well, right? It's like that. We want to compare our z null, the value that we found here, 2.53, and z at the half of the alpha. So what's going to happen is that our z null, which is 2.53, z at half of the alpha, it was 1.96 as well, right? You can consider, we would consider both sides of it. So because of that, we can say that our z null, it's greater than the z at the half of the alpha. So now let's go back to the graph that we had. So z for at the half of the alpha, it was 1.96 and minus 1.96, right? So these are the z at the half of the alpha. I just wrote down the value of that. What does it mean really? It means that from this point, which is our 0, right? So this length is 1.96. This length is 1.96 in the negative side of it. Now think about it. When we find out that this z observed is 2.53, so if I start from here, definitely I'm going to pass this, like I'm comparing the lengths. So here is going to be 2.53. So we are in the rejection area, right? So here is the null hypothesis. Like when we say that our mu plus minus, like our difference plus minus the margin of error. So it's going to be here. So we are in the rejection region. So we would say the conclusion would be we reject the null hypothesis. So we reject the null hypothesis. We reject to say that mu1 minus mu2 is equal to 0 or mu1 is equal to mu2. Right? So that's the, again, we reject that the mu of two populations, they are the same. So now we have this. Let's see what's going to happen with when we construct the confidence interval. So this is the conclusion that we made here. Reject the null hypothesis. For part B, it says that construct the confidence interval. For the confidence interval, we said that it's going to be mu1 minus mu2 between x bar 1 minus x bar 2 minus margin of error, and then x bar 1 minus x bar 2 plus margin of error. You can write down the equation of the margin of error here. Because I don't have enough space, so I wrote down like this. And now I'm going to find out the margin of error. I write down the margin of error here. So the margin of error, it's z at the half of the alpha. Right? You know, if you know the concept, it's very interesting in statistics. If you know the concept, what's going on with like what's the meaning of these ones, you even don't need to memorize this equation. You just can say that. It's like that for this one, it's like we find out this margin of error by considering the z equation, right? So the same test statistic that we had here. So it's like that this one is 0. We said that mu1 minus mu2 is equal to 0, right? So here I'm going to have x bar 1 minus x bar 1 minus x bar 2 minus margin of error. It's going to be less than this number, and like mu1 minus mu2. And then mu1 minus mu2 is going to be less than this number as well. So for this margin of error, I would say z at the half of the alpha times the standard error. Times. So what's the standard error here? So z at half of the alpha was 1.96. Can you tell me? Like, you can pause the video here and try to... We already wrote down the standard error somewhere in on this board, so you can say that. Just pause the video, think about it a little, and then like at least 10 seconds, and then come back and listen, like watch the rest of it. So this value here, this is my standard error. Like the denominator of your test statistic, most of the time, like 99% of the time, it's a standard error. So I would say it's z at the half of the alpha, and then write down this equation. Sigma 1 power 2 divided by n1 plus sigma 2 power 2 divided by n2. Awesome. So I have my margin of error. So it's going to be like, you would say, write down 4.1, right? 4.1 power 2 divided by the 18, and then 0.4 power 2 divided by n2, which is like 16. And then you will multiply it by the 1.96. And for x bar 1 and x bar 2, we are going to put down the 34.33 and 31.87. So we're going to do the computation. We put all of these numbers here. At the end, we will find out that our mu1 minus mu2 is going to be between like the two numbers. I did the calculation before, so it's going to be between like 0.554, and the upper bound of it is going to be, I'm just trying to use my memory, 4.36. Should write down. Probably I have it somewhere as well. Okay, so let's say this is the like 0.55 and 4.36. Now, when you look at it, what conclusion that you can make? What does it mean? So think about it for like for a few minutes, and then come back and listen to the rest of it. So it's like mu1 and minus mu2. 95% of the time, like it means that if I do this experiment like 100 times, 95% of the time out of 100 times, because the confidence interval is, we are developing the 95% confidence interval. So here I can write down construct CI or 95% CI, because we had the alpha here, so it would be okay if I just write down the like CI. So 95% of the time, the difference between mu1 and mu2 is going to be between 0.45 and 4.3. So there is no 0 in between. You can see that 0.5 is greater than 0. So in fact, even with this one, we are rejecting the null hypothesis. It's very interesting. So even with this one, we are rejecting that mu1 is equal to mu2. Right? So it's like the same things. So now we can understand it better. When we say here alpha is 0.5%, what does it mean? So it's like this 0.05 is a type 1 error as well, right? So it's like that for both of them, We have the same conclusion. So here we reject the null hypothesis, which was mu1 equal to mu2. And here we reject that mu1 is equal to the mu2. Okay, so we can make a good conclusion here generally. It's like that when we do the confidence interval or hypothesis test, we are going to get the same answer. So definitely we would get the same answer. So that's an example for the case 1 when we have 2 samples. So I can go on the side if you want to pause the video and look at the whole answers, right? Let me know if you had questions and I can give you more example about it.